Great. So my name is Segal. I'll get back to that in a second. I'm here to talk to you about serverless security. Somebody's running with something.
Is this your ticker?
Ah, I've got it.
One of the tickers needs to work.
That's mine. And as you know, I'm not getting really paid for this. So the only thing I ask from the crowd is to follow me on Twitter. Hopefully I convince you that that's going to be worthwhile for you by the end of the talk. So a little bit about myself. I'm the CTO and co-founder of a company called PureSec based out of Tel Aviv, Israel, focused specifically on serverless security. I've been involved in the application security field since the late 90s, starting with a small Israeli startup called Sanctum that invented the world's first web application firewall. If any of you were alive back then, it was called AppShield. And later on, AppScan, which today is IBM AppScan. I spent a few years after that at IBM through the acquisition, Watchfire in the middle. And then prior to founding PureSec, I was 5.5 years at Akamai leading the threat research team, again, based of Israel, responsible for all the security algorithms for the cloud security product line. I'm also the author of more than 20 patents in the field of application security, mostly around static and dynamic analysis, the inventor of interactive integrated IAST application security testing tools, and published a lot of research papers over the years, some of which are more known. I think this one, a remote code execution that I found in Apache back in 2002, also gives out my age. Yeah, I've been around. I'm also, and I think this is more interesting, the founder and lead guitarist for the Israeli art noise rock band Pitts. We have 3 albums out. You can go and listen to, if that's your thing. I warned you, it's a bit noisy. So today, and I don't have a lot of time, so we'll rush things a little bit. We'll talk a little bit about serverless security in a nutshell, explaining who's who and what are the different forces. We'll talk about a few of the different risks, and we'll actually experience them firsthand as we see some examples of pen tests that we've done and a live demo. So we'll get our hands dirty, and I'll leave you with a few action items. Now, I don't expect you to leave this presentation actually fully understanding what, serverless security, force of habit. We won't be able to cover all the top risks. That will take us about a day. So I just hope that you gain enough insights to understand where to look and where to read next. So looking at serverless security, a few years back, not a lot years back, but usually people would say, it's not my server, it's not my problem, not my infrastructure, I don't care about security. And then there were some talks about IAM permissions and open source vulnerabilities, but that was pretty much it until last year when we published the original serverless security top 10 document, if any of you bumped into it. And today, I think people already understand that serverless security is application security and needs to be treated that way with its own twists and serverless-specific things. If I need to explain to people what is serverless security, I usually start by explaining the shared model of responsibility. Just like with any cloud or public cloud infrastructure where the cloud provider takes some responsibility and then the customer or the application owner takes the other part of the higher part of the application stack. In serverless, we reach the highest, or today, the highest division of responsibilities where the cloud provider is responsible for basically everything except for your own code and configurations. So anything from, and it sounds funny, the physical security, the guards, the locks, the server racks, all the way up to the containers, or today it's micro VMs or whatever it is that's running your serverless functions. And then you are responsible for that blue part, the application itself, the application, the IAM roles, the configuration, the cloud resources, everything that is the application itself. And how much does it really divide between the cloud provider and you? So I did a little research. It's not rocket science. It's not that accurate, and the list is in small fonts for a good purpose. I don't want you to actually go and validate this, but Overall, this is a list of security tasks and responsibilities that you usually assume or have to take care of when you do PCI compliance or all of those other things, ranging from the physical all the way up to the users and the application, etc. And if you look at things like EC2 or virtual instances or infrastructure as a service, you see that the cloud provider is really not responsible for a lot, mainly the physical infrastructure and maybe the compliance and regulations that the physical infrastructure has to go through and hardening that infrastructure. And you're responsible for most of it. When you go serverless, things get much better. And this is sort of counterpoint to why I'm here, right? I'm here to scare you about security in serverless. I'm not really saying that. But the reality is that when you adopt serverless, you are starting at a much better starting point from a security perspective. There's somebody else that's much better than all of us in managing the day-to-day chores of patching the operating systems and the infrastructure and doing all of these annoying things that you've seen before. So in that sense, serverless is going to be, and that's my prediction, is going to be a huge boost to cybersecurity in general, which is terrific. I know you all know what serverless is, but I have to show this chart so I can show the next one. So looking at a very oversimplified, how serverless works, the developer pushes code to the repository, deploys it to the cloud. You have some event sources. I apologize for choosing only AWS icons. Those will trigger your function. The function will do some things, interact with other cloud services because no function is an island, and then hopefully, if everything goes well, we'll generate some output. How can an attacker even manipulate the business logic in such a case where the function is somewhere inside our cloud account? So we are seeing several attack surfaces, and remember, these are not the top risks. I'm not here to talk to you about SQL injection now in serverless. I'm talking about the surfaces. How can an attacker even gain access to your serverless application? So the first way an orange guy can do that is by injecting, come on, this was a joke. Thank you. By injecting data into the event that triggers the function. These functions get triggered by an event. You all know that. You're here because you know that. And if the event is an HTTP request, then it's obvious where can an attacker inject malicious input in the parameters, in the cookies, HTTP headers. We all know that for many years. But what happens when we're talking about a cloud-native event, an SNS event, SQS, blob storage, cloud, I don't remember all the name of those things. Each of them comes with its own set of input fields, each with a different encoding scheme. It's not always URL encoded. Sometimes it's zip encoded. Sometimes, for some reason, it's base64 encoded. If there's one thing we can say about serverless events are that they're still not standardized. So that's one way, and obviously, just as a user can control some of the fields, an attacker can control these fields and inject some malicious data. That's one way. And the other way is by deploying code in an unauthorized manner, out of band, not through the normal CI/CD. How would somebody do that? I can give you at least 3 ways. The malicious insider, disgruntled employee, we don't care about that. Second one, somebody runs a cross scripting or a phishing attack at one of your developers, steals the credentials, deploys code directly to the cloud. Another way, through the code, by poisoning third-party open-source dependencies. There have been several such cases in recent months. I think the last one I remember is the NPM package that ran Bitcoin mining, right? And so that's really not unique to serverless. The unique part is that when you use open-source libraries in serverless, and we do that a lot, mainly because we're trying to keep the functions as small as possible and reuse code, we have no control over the runtime environment, and so we can't monitor what these open source libraries are doing. It's much easier to detect what they're doing when it's on-prem or on our own instance. And last but not least, an attacker can try to manipulate the function by manipulating the data that the function consumes during execution. So not from the event, that's one attack surface, but for example, a function that runs and accesses blob storage or S3 buckets during execution, if that is publicly open, and it's not like we've never heard about a publicly open S3 bucket, that can affect the function as well. And what can an attacker gain? Everything that we know from the world of application security. from compromising data, abusing the business logic, leaking secrets, denial of service, and its sibling in the serverless world, financial resource exhaustion or denial of wallet, code execution, etc. You'll see some of those in a second. I said I won't go into the top 12 risks. Last year we had the top 10. This year we decided to take it all the way up to 12. Another joke. Wow, you guys are really after lunch. I keep getting a crowd after lunch and talking about security. That's a tricky thing. Go download the document. I urge you. It has a lot of very useful information on all the public cloud vendors out there. So, I'm not going to pitch any products, but there is a need for a different type of application security solutions that are serverless native. If you look at traditional application security solutions, web application firewalls, runtime applications, self-protection, and even their counterparts from the network security world, IPS, IDS, endpoint protection, etc., that you do use to harden your environment, they all require some sort of infrastructure to run on. And in serverless, by definition, I don't have to tell you that, the only thing you control is your code and your configuration. You can't really deploy a runtime agent like a RASP agent. And a web application firewall would help you to protect a function that is tied or bound to an HTTP event trigger, but any other type of trigger, that's not going to be really useful. To put it into a diagram really quickly, you take an application. Today, in order to give it like a 360 robust protection, you install endpoint protection on the host, IPS on the network, web security gateway to inspect outbound traffic, next-gen firewall to inspect inbound traffic, web application firewall, of course, and you put all of that on the infrastructure, and when you go serverless, you send away the infrastructure, you break the application into functions, and they're basically out there in the cloud or on the internet as we know it. And if they're available to your customers, they're available to attackers as well. And there's nothing in there other than your code or how well you wrote the code and how well you configured your application to protect. So everything is reduced to good coding. Good luck with that. So now that I did that was the introduction. Let's talk about a few important things, and I mentioned that IAM roles is going to be one of them because we can't really escape that. List privilege, everybody knows about the concept of list privilege. Terrific. Obviously, when you develop serverless functions, you want them to be list privileged. Each function, by the way, in most cases, you would want it to adhere to another very important principle, which is the principle of single responsibility, I believe. I saw some nodding, so I hope it's not something else. But what does it mean? It means that if you have a DynamoDB client or a database client and you use .putItem API call to insert items into the table, you really want to only allow the function to do that. That function should never be doing anything else. The IAM, at least the AWS IAM role, and I believe that's now also the case in Azure and about to be the case for Google Cloud Functions, allows you to use very granular IAM roles and permissions in ways, by the way, that we could never do in monolithic traditional applications. IAM roles done right, and I'll get back to that in a second, coupled together with a good well-designed microservice design, can go a long way in protecting an application by itself, these two concepts. And you will see that in a second. However, the human factor plays a role. As always, developers found a way to make life easier for them and easier for the attackers, and they use wildcards. When you use a wildcard, by the way, and here's the quiz, if I need to use putItem, which permission do I have to use in CloudFormation or in IAM in AWS? Can anyone name and spell the right permission? Go ahead. How do you spell it? Yeah, it's putItem in camel casing because that's really makes a lot of logic. So it's not very easy to map. Sometimes it makes a lot of sense, but it's not entirely easy. Now, it's very easy when you have one function, one role, 10 functions, 10 roles, when you have 100 functions and you have to start working with rows, that becomes a problem, which brings us to the most common problem that we see today in serverless. And that is using wildcards. And when you use wildcard for DynamoDB, it's important for you to understand. You're basically granting the function the ability to do any kind of action on that resource. Worse, if you put an asterisk, a wildcard on the resource, you're granting the function permissions on everything. And you will see in a second why that's a problem. As I mentioned, we ran some scans across thousands of applications on GitHub, all the open source, the examples, everything you can read. Large chunks of them, more than 21%, had critical wildcard permissions. So this is very common. And as I mentioned, if you use IAM permissions together with the principle of single responsibility for functions, you develop microservices. When something bad happens on a single function, you're basically limiting or containing the damage. I tried to do some damage here, but that didn't really work. And you will see in a second why. So here's an example. Back in August, last August, this is, anyone knows who this guy is, by the way? Okay, Caleb Sima. So Caleb, who's an old friend and a competitor who founded Spy Dynamics, if anyone remember that company. Caleb decided to do a challenge. He's very intrigued about security, and he wanted to know whether people can do some serious damage to his AWS account, given that he created a Lambda that gives you a shell. Now, needless to say, in any other scenario when an attacker gets a remote code execution, that's pretty much game over. That wasn't the case here. And so I got the challenge, and I said, OK, this is interesting. I can see some benefit of winning this challenge. Let's see what I can do. The first thing I did was type env to get the environment variables. And it was very interesting to notice, and everybody knows that in the environment variables, you have the session tokens that the function gets through the STS service, I believe. Those are that's the temporary credentials for the function to do what it is that it needs to be doing. And so I said, that's interesting. I have all the tokens. Why do I need to use Caleb's screwed up web interface if I can just set these environments locally and run the commands as if I was that Lambda function? And that's what I've done. So I took the environment variables, which were freely available to me, exported them, and then in order to check what's going on, I basically called the STS get caller identity, and lo and behold, I discovered that I'm now running under the Lambda's basic execution role. But Caleb wasn't stupid. As you can see, he gave it the Lambda basic execution role, which doesn't allow it to do a lot. I didn't know that yet. I was like, OK, I'm Lambda. Let's see what Caleb granted the function, what permissions, and I'm going to wreak havoc here. And so I started doing things. I started running list functions, and then I got an access denied. And then I tried get function, and I got access denied. And then I tried listing buckets, and I got access denied. And that's when it hit me that Caleb wasn't actually that stupid. He created a role that is list privileged, and I'm pretty much screwed up. I can't do anything. And so, assuming at that point that and that's, by the way, when it hit me that with good IAM permissions, I'm stuck with a remote code execution that grants me nothing. The only thing I could do was write to the CloudWatch logs, which is not very sexy and doesn't really give you a lot. And so I said, maybe there's some S3 bucket. I know that when I develop static websites, I usually create a bucket with the name of the application. That's very common. So I tried S3 API, head bucket over that bucket, lambdashell.com, which is the URL of the website. And I got an empty response, like nothing. And so I said, OK, that's weird. An empty response, does that mean that I found the bucket or that it doesn't exist? So I tried a different made-up name, and I got a 404 response. And then I was a bit happy. And so I decided to, OK, I know there's a bucket with that name. Let's try to list the contents of the bucket. And I listed the contents of the bucket, and I actually got the contents of the bucket, which was very interesting, because suddenly I found something I can do. And so then I said, OK, that's interesting. I can list the contents of the bucket, but can I write into the bucket? And the only thing that came to my twisted mind was, how do I test for write permissions? Of course, I delete a file. And so I decided to delete index.html just as a joke. I think I didn't really expect that to work. Well, it did. 2 hours later, I get a phone call from Caleb, and he was at Black Hat, that was, as I said, in August, telling me that the site is down, nobody can do anything, and he's in Vegas, so for 5 days the site was down. Wasn't very fair for the competitors, but I got what I wanted. By the way, he still owes me $1,000, and if you follow me, my presentations, it's the same thing every month. He still owes me the $1,000. So how do you get IAM permissions right? And that's very tricky. First of all, adopt a role per function model. Now, I'm here, I'm very brave and very, telling you, hey, use a role per function, while you go back home and you see that you have an application with 500 functions, and now I'm telling you to do 500 roles. That's the best I can do. Second, think twice before you actually use an asterisk. Most cases, you don't need to use a wildcard. Use SAM-managed policies. If you are using SAM, and I highly recommend using SAM, they have those built-in managed policies. Obviously, even in that realm, you can do mistakes. That's not the kind of SAM-managed policy that I expect you to use. The second one is. There's a plugin, I believe, called a role per function for serverless framework. Actually, that's the other one. But you can do custom roles per function. And my company, I'm not going to mention the name with the logo on the back here, created an open source tool that scans your code, understands which APIs you're calling, and then generates a least privileged role for you automatically. Huge time saver. You can download it. It's free. It's open source. You can do with it whatever you want. OK, now we'll jump to app DOS, redos. How much time do I have? Plenty? Good, because I have a demo, so unless people are falling asleep. OK, you know this guy? I'll give you a moment to read. So this is Corey Quinn, and Corey has a mailing list that deals with improving your AWS bill. And Corey and I were talking before the last reInvent, and he said, you know what, if you break into my application, I'll post something about you, and I'll even use the PureSec product. And I said, you know what, OK, terrific. And he said, and he did give this disclosure, it's very simple. It's just the registration form, the Lambda behind the form. I don't suppose you'll find anything. And so he actually granted us access to the source code. And we looked at the source code, and we saw that he was using a library called SendGrid. I'm sure that most of you know it. And then inside there, he's calling, like he's instantiating an email object by taking the email and creating an email object. And that library actually uses the Python email library. And that library supports these old email formats, the long ones where you have the name, the real name, and then the email, based on that RFC. And I have a thing for reading RFCs. I have to admit that. So going through the RFC, I read and I figured out what was going on. And if there's something that does that, obviously there's a parser here. And if there's a parser here, there's a party here, usually. I love those situations. Usually people screw up in parsers. And so apparently, after digging through the code, if you send that, and it should be like 100 kilobytes, I started with a small email, it hangs. It hangs for a second, for a millisecond, actually. When you get to 100 kilobytes, it hangs. It hangs for 2 seconds. Now, that's not fair, really, because it's not really a serverless attack, right? I'm just doing an app, a redos attack. But if you post this 1,000 times in parallel, there you go. So I thought that this would be, OK, it will go down, it will go up immediately, right? Auto-scaling, cloud, all that thing. It was down for a good 5 minutes. I can't explain that. Next week, Corey wrote this nice mention, and he blogged about it, and I blogged about it. And we got that traffic spike that he promised us. I want to jump to the demo because I don't have a lot of time. How much time do I actually have?
Like 15 minutes.
Wow. So last example. Last year, I was looking for some libraries to help me with something on AWS Lambda. And again, it's not that I'm targeting Lambda here. It's just, that's what I found. I found this library, this NPM library that does multi-part parsing. You all know what HTTP multi-part is? Terrific. We're now going really back to the 90s. So in a multi-part, instead of sending a parameter equals value, ampersand parameters equal value, you split the body into, I guess, parts, hence the multi-part. Each part has its own parameter, and then you can also put like base64 stuff in there with attachments, etc. And the way the browser and the server know where the part starts and ends is by the boundary string that you define in the content type header. That's terrific. And that library that I noticed that was created for Lambda was actually using the boundary inside the regular expression itself. So they took the boundary that was sent by the client, used it inside the regular expression as the pattern. Big mistake. Here's the boundary that I chose. Okay, that's like the worst case regular expression you can create. And lo and behold, that got stuck for a good, timeout, I guess. And then thousands of those, and it's down. So let's do a demo. Now, I think by now we covered a little bit like injection attacks, third-party libraries, IAM permissions. Let's see how we take all of that and use it together to attack a very realistic application. This is here because usually there's this thing with the demo gods. OK, so let's see. Oh, I have one more slide to explain the demo. OK, so the demo is an HR application where a candidate will send their CV as an attachment to the email. The CV will get, ooh, you're not supposed to see that. The CV will go through the Amazon simple email service that will pass through SNS to trigger Lambda. The purpose of Lambda in life is to extract the attachment, turn the PDF into plain text, run a candidate qualification algorithm, textual analysis that we developed, and store the results in a NoSQL DynamoDB table. In parallel, it will send an email back to the candidate that we're handling the CV. And I went the extra step and created a web interface for the HR team to invite people to interviews directly to the DynamoDB. So that's the demo. And let's see how the application actually works. Is this too small? Because I can do this. OK, I'll do that when we need it. So let's send an email to the HR team. Let's call ourselves John Smith. My CV is attached. And I'll attach the CV. And this is not the CV. This is the CV. The CV is a normal PDF file. I promise you, I didn't plant any malware in it. And we'll take that. We'll put it inside the email as an attachment. And we'll send it. And what happens now is very cool. Serverless is happening. SES, SNS, Lambda, parsing, extracting the text, storing to Dynamo, sending an email back. That should happen right now. There it is. $0. Yeah, OK. Now, indulge me. Let's say we are a candidate that didn't get accepted to the job, and we want to get a revenge with the company. And now we are after their crown jewels. We want to exfiltrate their database of sensitive information and leak it out to the internet. How do we do that? 10 years ago, I would tell you, OK, there's a web form. I'm going to fuzz the form fields, use SQL map, some fuzzing tool, find the SQL injection, command injection, exploit it, et cetera. But I'm using email here. So my interface is email. I can't really fuzz anything here. I'm not expecting to knock down the Amazon host managed email service. So what can we do? Let's see. So we need to be a bit more creative than SQL injection here. And Frankly, I don't expect, by the way, if I do send malicious input in an email, to get like a stack trace with debug information back like we showed 15 years ago, right? That doesn't make any sense. Nobody writes applications like that anymore. So we need a different trick. So what I'm doing, I'm copying the file. We'll use the same file, and I'll change the file name. And it's very, it's OK to assume that the file name is being used somewhere down the line inside the system, right? Maybe copying the file, extracting the PDF. So let's try to manipulate with the file name, and we'll try to do something like that. I'll do John semicolon, and then sleep 5,000. And here's the trick. Because I'm not expecting to get any instant feedback, right? It's not like I'm sending an apostrophe and getting a 500 error back with some stack trace. I need to sense that the application is vulnerable to something. And how do I sense that? I use time as my ally. I use a time-based probing approach. That's a very common attack technique that attackers use, especially in the web world. So we'll do a semicolon, sleep. In case the file name is being used in some shell interpreter environment, maybe the semicolon will break the command, and maybe our sleep command will work, and we'll attach that. That's obviously .pdf at the end, because every file has a sleep 5,000 semicolon in it. And we'll send. We don't have 5,000 seconds, but you will have to trust me that this actually works. In fact, it took about 10, 15 seconds earlier to get the email back. We're not going to get the email back, so we know that the function or the application is vulnerable to code injection through the file name. But what can we do with it? How can we get access to the data? We still don't know anything about the function, right? We need to somehow extract the source code of the function to turn this from a black box into a white box engagement for us. How do we do that? So we have code injection in the file name, and we can probably inject some commands, but how do we fetch or send us the source code? Because I don't want to type this long payload, I'm storing it on pastebin. And I'll show you how we can use it. So it's hosted on the internet on pastebin. All the source code does here, the malicious code, is extract the name of the handler, the name of the file, and open it and read it and send it into an email. Now, right now, it's a static file on pastebin. I need to get it executed somehow. And how do I do that? Very easy. Like this. So instead of semicolon sleep, I use semicolon curl to silently fetch the payload that you just saw from pastebin, and then pipe it into a Python 3 child process. Makes sense? Obviously, I need the .pdf at the end, or else it wouldn't be a file name. And that's it. I encoded it a little bit, but yeah, let's see it working. And we'll send. Now, very important. We are not violating any security policy, okay? Remember that. My code is now running under the Lambda's function main process with its own permissions. The Lambda process is obviously allowed to run curl and fetch stuff from the internet and run Python child processes. And so, if you now look in CloudWatch or in CloudTrail or in App Insights, bless you, you will not see any error violation. You will not see a trace to the fact that we just exfiltrated the source code. And you see the function is still running normally, but it also returned the source code of the function, which is here. Nice. Now, I'm not going to damage your eyes with this black and white monochrome source code, so I already loaded it here in Visual Studio Code. You trust me, it's the same one, right? Terrific. Let's see what the developer is doing. And remember, now we're with our black hat on, OK? So we see that the developer is defining some sort of a table name, taking it from an environment variable. At least it's not hard-coded, which would be like even worse. But as you will see, we can get the table name in a second. Then creating a DynamoDB client, and then getting the event, going through the records. It's an SNS event. Get the payload, get the file name. Good security practice. Check that it ends with a .pdf. Terrific, which is, by the way, why I always use a hash sign .pdf at the end. And then mistake number one. And this is the crucial mistake. This is where the developer is trusting user input blindly. Oh, I didn't take that off. what's going on? The developer is using a very common CLI tool called PDF to text, which does exactly that, and embedding the name of the attachment directly into the command. I don't have to teach you that this is exactly how injection attacks start. Basically, when we typed semicolon whatever, sleep 5000, we broke the command into two. The first part, the developer's original intent, and our own code, which sent stuff and ran stuff, and etc. And here's the interesting part. The developer is taking the Dynamo client and then using dynamo.putItem to insert data into the NoSQL database, data from the email. This is the exact table that we now want to exfiltrate. Can you guess in how many emails it's going to take us to exfiltrate the data? Yeah, 1. So what do? We create our own Dynamo client. Of course, we're allowed. We're running under the main functions permissions. And then we run dynamo.scan, which is basically like select everything from the table. What table? The table that the developer defined in the environment variable. You see why you need something better? And then we dump the response back to the email, and that's it. So how do we abuse that? Same trick. Let's put something funny here. And then we'll take the second payload. It's exactly the same as the first one, just with a slight change in the paste bin URL. And we'll put it here, and we'll hit send. And here's the cool part. It took us 3 emails from probing to exfiltration of the full table. And if this was like a web app and I had to deal with blind SQL injection, that would take me thousands of HTTP requests to extract every single character. If you ever used automated tools, you know why you need them. Here in this case, because we are running under the Lambda's permissions and the developer obviously made a mistake, which we'll get back to in a second, we can exfiltrate the entire table in 1 email. Very under the radar, very fast and low, I guess. And here's the table. Entire table in the email, and then we can sell it to, I don't know, whoever. Back to the slides. I promised to say, OK, why am I even allowed to run dynamo.scan? Because the developer did this. OK? Let's go back to the slides. Questions up until now? OK, I'll leave time for questions at the end. Let's see the demo. And how do you take action? Yeah, I need to switch the screens. So as I said, it's not fair to expect that I will teach you about serverless security in 30-something minutes, especially after lunch. If it was after breakfast, there would still be some chance. But what I think you should be doing is, first of all, download and go read the, and this is now a CSA document, by the way, and you can contribute to this effort. The CSA Serverless Security Top 10 Risks. It has a lot of, for every risk, we actually list the mitigation best practices for each of the main 4 public cloud platforms, as well as compare that to traditional applications. There's this terrific application, I can't actually attest because I wrote it, called Serverless Goat, which is an OS project of a vulnerable application very similar to what you've just seen, where you can download, you actually don't have to download, it's deployable through the AWS app repo. So it's a single-click button installation, and you can already play with it and hack it. It has a lessons file in the GitHub project, and you can, already by Monday, you can start bragging to your friends how you know how to hack serverless applications. Taming open source third parties, I didn't talk about that a lot, but PureSec has a free library, and it's completely free, called Function Shield. I can maybe show it in the browser here. You all know Jan, right? So it's a free library. You download it once. You can use it across your entire organization. You owe us nothing. And it can do 4 things and do it very well. Disable outbound internet connectivity from your function. Disable read-write operation on the /tmp directory if you want it to be entirely ephemeral. Disable child process execution in case you don't expect anyone to do buffer overflows. And prevent source code leakage, exactly what I've done here. It's very, very simple to use it. It's basically a switch, and like you create an instance, and then you block or alert or whatever you want to do, and you start getting a ton of logs about what's going on with your function. Right now, it supports Google Cloud Functions and obviously Lambda, and we'll add additional platforms soon. So that's Function Shield, and I'm mentioning it under the third-party libraries because you can use this exactly to log what those open source libraries are doing when the function is running in the cloud. Last but not least, that open source IAM list privilege role generator. Twitter moment. Role generator, you can download it. It's open source. You can also contribute it. But in general, it will scan your Lambda project. It will generate list privilege IAM code snippets for you, so you can just copy and paste that. I think I'm done if there aren't any questions. And I'm here having a bit more coffee because I'm about to fall asleep. So you can come ask me questions. Yes? It has a microphone in it?
Yes, I suppose so. Yeah,
wow,
there we go.
Okay.
So
that
there was
sense.
someone demonstrating a famous NPM exploit by renaming the function fetch and making it basically invisible. And if you downloaded a cute package that would color your log lines just for fun, then it would also transmit all the data. So when you say blocking outbound requests, is this also based on the function level, or is it like a real firewall, as in, hey, something tries to fetch, it's not allowed to, let's not make it do it?
Terrific question. It's actually much lower level than the function itself. You can't outsmart it. So it will block and log any outbound connectivity from the process of the function and downwards on the operating system level. Yes.
Okay, thanks.
Sure.
Here you go.
Usually we don't get security questions because it's like Alcoholics Anonymous. Nobody wants to say that they have a problem, right? Yeah.
So do you think that it's safer to write the functions in a compiled language like .NET, C# or Java? Does it make it safer?
Safer?
Yeah.
No? Why?
You cannot get the code, maybe?
You can, actually. It's not really compiled. You can reverse engineer the bytecode.
It makes it.
We actually do that.
More complex, I think.
No, not for bad purposes. We scan. As a service, we scan our customers' infrastructure. They're already deployed functions to detect vulnerabilities and misconfigurations. We need to scan bytecode as well. So yeah, that's what I meant.
Yeah.
So let me repeat, because it's compiled, it will take you more effort to get something executed, right? That's the whole trick. And if you're doing it in, let's say, Node.js, it's interpreted. So once you get a file on that system, then it's okay, right? I think that's a benefit of doing it in a compiled way instead of interpreted.
Yeah, there are benefits to each approach. Actually, there are benefits to that, to those. I don't really know what the benefit is, other than ease of development for runtime languages. But yeah, so it has better chances of dealing with some of the, let's say, more low-hanging fruit for attackers, like injecting commands. Like I've seen that in Java, like the struts vulnerability and things like that, but it's much more rare, yes. Anyone else? If you buy me good coffee, I'll give you a course on serverless security. I'm still looking for good coffee. Thank you very much, of course.
Thank you.